AP Stats Review number 3. This packet is all on probability. It's about 30 to 45% of the test, so you can expect to see about 12 to 15 of the multiple choice questions out of the 40 total questions and 2 of the 6 questions out of for the free response. Now, that doesn't mean 2 straight questions, but that means partial questions, sometimes full questions. And this is not just the probability on the probability unit that we did doing independent probability and things like that, but it's also the normal probability, doing the normal curve that we've been working with all year long. All right, could you please go ahead and open up to your packet and your probability? Those of you that are online, I posted it on the calendar so you can print it, and those of you in person should have a copy. If for some reason you don't have a copy, go ahead and get just a blank sheet of paper out and take notes, and then I can make sure that you get a copy at some point. All right, so I'm going to start out with the basics of probability. On the first part, it says the first thing you need to do is to make sure you look at your AP formula sheet and check out the formulas that you're given on the probability. So I'm just going to kind of go over a couple of those. So the first thing that you are given on your probability sheet is the probability of A, given B, is the probability of A and B over the probability of B. And the other that you're given is the probability of A or B is the probability of A plus the probability of B minus the overlap, which is the probability of A and B. I wrote that, I meant to say it wrong way. That should be or. So these are the two that are given to you on the actual formula sheet, and we're going to talk about kind of some of the different things that occur. Okay, so this is given to you. It says, suppose probability of A is equal to 0.35 and probability of B is equal to 0.6 and A and B is 0.27. What's the complement of A? Remember, the complement of A is just 1 minus the probability of A. So obviously that's going to be 1 minus 0.35, which is just going to be 0.65. Now, I really recommend for you, if this were your AP test, for you to write that out exactly like that. It just demonstrates complete understanding. If you were to put 1 minus 0.35, let's say you put 0.75 is the answer. As long as you had all of that work, you would not get marked off for having a transcription error is what we would call it, or some sort of mental error, because you're obviously showing what process, you're obviously showing the correct process that you need to do to have this. So, okay, so let's go ahead and see the next part, and which is the probability of A or B. Let me get on here real quick. Okay, the probability of A or B is, we have probability of A plus probability of B minus probability of A and B. You don't necessarily have to write that out, but I'm just going to go and put the numbers right in. So the probability of A is 0.35 plus the probability of B is 0.6, and the probability of A and B is 0.27. So I would make sure that I would just go ahead and write that out just like that and go ahead and solve this. Okay, which is 0.68. Okay, the probability of A given B. So the probability of A given B is the probability of A and B, which is 0.27 divided by the probability of B, which is 0.6, and that gets you 0.45. Let's talk about that. Remember, this is saying what's the probability of A occurring given we know what happens to B. We know B occurs. So this is that I'm saying that if we know 100% we know B occurred. What's the probability of A happening also? So if I were to draw this out, this is what it would look like in a Venn diagram. So this is A and this is B. Really, it should be outside the circle, I guess, because that represents that it's just in that small part. So it's really A and B. So I'm saying I know 100% B has occurred. So there's B. We know 100% B has occurred. So what's the probability that A A occurs in B. And so it would be that gold part, the probability of A and B, over the entire blue area, which is including the gold part here. And that's where those numbers come from. Okay. I didn't demonstrate this one here, but we can also demonstrate this one in what's the probability of A plus the probability of B. And then I subtracted that overlap because you can see that I counted it 2 times. That's why the 0.27 was that overlap, and I counted it twice. Okay, are A and B independent events? Or to know that they're independent events, I know that the probability of A given B would have to equal the probability of A. That's one way to show it. The other way to show it would be the probability of A and B would have to be the probability of A times the probability of B. These are only true if A and B are independent. If A and B are independent, then this scenario here is true. So that's what we're going to check out. So what's the probability of A and B? Well, we already solved it up here at 0.45. And what's the probability of A? The probability of A is 0.35. So this is what I would say. I would say, since the probability, I would say the probability of A and B does not equal the probability of A, as shown above, because I've already shown it. If I didn't show it, I would go ahead and put the numbers in. So A and B are not independent. The other way, as I said, you could show it is this. So we can try this also. Probability of A times B. So if I have 0.35 times 0.6, does that equal 0.27? And no, it does not. You can go ahead and multiply it out, and you can see that that is also not true. So either way are legitimate ways to show its independence. Sometimes you're given information to show the first way. Sometimes you have information to show the second way. So that's why I make sure that you know both ways. Sometimes you're given information to show both of them, but you have to make sure that you show the correct one. Okay, example number 1. Let's go ahead and look at this. It says, suppose the probability of a construction company will be awarded a certain contract is 0.25. The probability that it awarded a second contract is 0.21. The probability that it'll get both contracts is 0.13. What's the probability that they will get at least one of the 2 contracts? All right, I'm going to give you a second to go ahead and do it. You can solve this with a tree diagram, a Venn diagram, a chart, or anything that you want. The way I'm going to do it is I'm going to solve it with a tree diagram. And so I'm going to stop for a second and let you try to solve it.
Where's your mom? What? No, I said you're. Where's your?
She's taking a video.
Pardon?
She's taking a video for school.
Oh.
Okay, so this is, hopefully you've solved it by now, but we have here. So it says, suppose that the construction company will be awarded a certain contract is 0.25. So I have contract 1. So contract 1 and no contract 1. So the probability I've got the contract 1 is 0.25. Contract I don't get it is 0.75. So now let's say what's the probability of contract 2? And then no. So that I get no contract 2, or sorry, contract 2 is 0.21. And no contract 2 is going to be 0.79. So contract 2 again, because I could have the possibility that I don't get contract 1, but I do get contract 2. Okay, so then it says the probability that I get both contracts is 0.13. All right, so it wants to know what's the probability. So if I have the probability that I get both contracts, so the probability of contract 1 or 2 is going to be the probability of contract 1 plus the probability of contract 2 minus the overlap of the probability of contract 1 and 2. So the probability that I get at least 2 contracts, which really honestly, I guess I I drew this out. You don't really need all of this drawn out because I showed you the formula wise, but you could have done it that way. So the formula just works out just fine because if I plug all these in, the probability of the contract 1 or contract 2 is going to be 0.21 plus 0.25 minus 0.13. And that's going to be your total here. And let's go ahead and add it up, which should be 0.33. Yeah, 0.33. So you would then write the stem of the question. The probability that this company will get at least one of the contracts will be 0.33 because that would be one or the other or both. That would be what that would encompass. Okay, example 2. I'm going to give you just a moment to go ahead and do example 2. A researcher interested in eye color versus success in math program collected the following data from a random sample of 2,000 high school students. Find the probability that the student from this group fails the math program and then continue to do B and C. I'm going to give you about 2 minutes to go ahead and do that.
Is that today's work? You can still hear me.
Okay, let's see. The probability that the student from this group fails the math program, so we're going to say, okay, total fail is 200 out of 2,000. So probability fail is going to be 200 out of 2,000. Of course, you can go ahead and solve that and simplify it, which is 1/10 or 0.1. What's the probability that the student from this group that fails the math program given, here we go, here's our key word, that he or she has blue eyes. Okay, so that means the only thing I'm interested in here on this problem is the blue-eyed group. So I have to be the blue-eyed group, but I want to know how many of my blue-eyed students fail the math program. So I have 10 out of 100. So that is the probability of, if you wrote it out correctly, it would see blue-eyed, oops, sorry, I didn't do it correctly. So fail given blue eyes. And that's going to be 10 out of 100, which is 1/10. Are blue eyes failing the math program independent or dependent? Well, we know if, this is how I'd write it out, if probability of fail given blue is equal to probability of fail, then fail in blue would be independent. And lo and behold, yes, they are. 1/10, 1/10, yay. Okay, so yes, they are independent. So yes, 1/10 equals 1/10, so they are independent. Cool, all right. All right, example 3. Go ahead and do example 3. Let me give you a couple more minutes on this one. Let's see. So of the 60 obese teenagers in a recent study, 15 had type 2 diabetes, 20 had high blood pressure, 10 had both. Suppose that one of these 60 teenagers is randomly selected. Given that the teenager has type 2 diabetes, what's the probability that he also has high blood pressure? Okay, go ahead and take a couple minutes to solve A and B. All right, so the first thing we're going to have to do is we're trying to find given that the teenager has type 2 blood pressure, what's the probability that he also has high blood pressure? So we have high blood pressure given type 2. Okay? So I'm going to try to find the probability of high blood pressure and type 2 over the probability of type 2. So do we have, let's see what information we have. It says of the 60 teenagers in the study, I had 15 had type 2. So I have 15, that's going to be 15 out of 60 because it tells me 15 had type 2, 20 had high blood pressure, and 10 had both. So this up top is going to be 10 out of 60. So this is just going to be 10 over 60 over 15 over 60, which is clearly going to be 10 over 15. which is 2/3, or 0.67. If the obese teenager does not have high blood pressure, what is the probability that he also does not have type 2 diabetes? So the probability of not high blood pressure, the complement of that, given they does not have type 2. So that's just going to be the opposite. So that's going to be, I know that 45 out of 60 do not have type 2 diabetes. Oh, no, did we get that right? Hold on. We had, all right, 15 that do, but let's see how many that don't. So we have the probability that have type 2 is that I have 15 out of 60, so the probability that don't, but that's only type 2. Yes. Okay, and then the probability that they don't have high blood pressure is the opposite of that, which was 50 out of 60. No, I did something wrong. Hold on a second. I think I've messed this up. Yes, I did. All right, so let's look at the work here then. So the probability that they has high blood pressure is 20. Oh, and here. So that's 10. So high blood pressure, 20 out of 60, and the high probability of both is 10 out of 60. Okay, and so if I were to make a chart, let's do that, because it looks like I've got, obviously this is going to be too high, so that's not going to work, because if you try to do this is the complement of those that completely don't have type 2. So these are mixed in with those that have type 2 and those that have, that do not have both. So you're going to have to, let's make a little quick chart so we can see what we did. So we have type 2, and we have yes, no. And we have high blood pressure, and we have yes, no. So let's go ahead and fill this out. So I have, of 2, I have 15 out of 60 that have type 2. And those that have both was my 10. Oops, that's yes. Nope. Try that again. Okay, so this is 10, and that's 15. There we go. Now that's better. Okay, because I have 10 that have both, and I have 60 total, so that's going to be 45 there. Okay, and then the rest here is going to be, what else do we have? We have high blood pressure and both is 10. We have high blood pressure is 20, so yes, high blood pressure is 20. So that's got to be 10, and that's got to be 35. There we go, 40, and that matches up. Okay, so we're looking for if the teenager does not have high blood pressure. Oh, well, that's the problem, is that I wrote the wrong equation anyway. So let's try that again. If the teenager does not have high blood pressure, so not high blood pressure, what is the probability that he also does not have type 2? Okay, so we're going to do the same thing. I'm going to do the probability of not type 2 and not high blood pressure over not high blood pressure. All right, so let's look at our chart that we made. So let's look at those that do, which are no-nos, basically. No, which is 35 out of 60. There we go. And then how many do not have high blood pressure? And so if I look at those that do not have high blood pressure, which is 40 out of 60. There we go. And the answer then would be 35 out of 40. And yes, you could just go ahead and reduce that. Okay, let's go to example 4. The probability that Michael misses a free throw shot is 0.1. So this is misses. If he goes to the line to shoot 3 free throws, which that's going to be on a 3-point shot, kind of like the one that we saw in class a couple months ago when we did the basketball video. What is the probability that Michael misses all 3 shots? So that's going to just the probability that misses all 3 is just going to be 0.1 to the third. 0.1 times 0.1 times 0.1. And the assumption we had to make is that they were independent shots. Because remember, we learned way back up here, if it's independent, the probability of A and B is equal to the probability of A times B. So if the probability miss the first one and miss the second one and miss the third one, that gives us permission to multiply all the probabilities together because it is on the understanding that it's independent. So that's exactly the assumption I need to make. Okay, what's the probability that Michael makes it at least one? So makes at least one. Let's do what's one minus the probability of making none. So we know that making none is 0.1 to the third, so it's going to be 1 minus 0.1 to the third. And yes, you would go ahead and put all of those in there, which 0.1 to the third, of course, is 0.001. And so this is going to be 0.999. Whenever you see at least one, you want to do 1 minus the probability of none. The reason being is that to be able to add up all of the different combinations of, okay, I could make the first one but miss the second. I could miss the first one, make the second, miss the third, make. I mean, there's a lot of different combinations. With a combination of 3 and just making 1, it's not too bad. But if I start doing 4 or 5 or 6, it becomes very difficult. So it's a lot easier just to say, okay, this is the probability of making none of them, and then subtracting that from 1. And part C, what is the probability that Michael makes the first shot but not the second or third? All right, so he's going to make the first shot, and he's going to miss the second one, and he's going to make the first one. That's right, sorry, messed that up because making is 0.9. So he's going to make the first one, which is 0.9, and he's going to miss the second one, and he's going to miss the third one. Okay, and that is going to be 0.009. Okay, what I'd like you to do on your own is let's go ahead and I want you to try to do 5 and 6 and 7 here. We'll start with binomial distribution tomorrow together, but I'd like you guys to go ahead and on your own do 5, 6, and 7, and when you do your packet upload, stop here and then upload here. And I will give you a recorded lesson tomorrow, and I will see you guys back in on Thursday. Thank you very much. Have a great day.